Hello, it's good to see you again today. In today's session, we're going to talk about analog input and digital analog converter. And later, we're going to practice how we're going to read analog input into our Arduino. Alright, first of all, let me ask you this question. What is analog? Well, if you look around yourself, everything around us is actually analog signal. Like we have temperatures, we have pressures, we have speed, everything. They are all analog. Or even when you play with your game console. Right? So what is analog? Well, analog is actually continuous value or continuous variable signal. That means rather than we have something like true or false, high, low, we may have something like 75, 94, 1.3, like that. So think about it, everything is actually analog signal, like your temperatures and the signal that's passed to your television set at home as well. However, we also know that our computer is a digital system. It is a digital computer. That means our computer can only handle high and low, not arbitrary value. But how can we use analog signal with our computer system then? The answer is we need an analog to digital converters. The idea is that we have an analog signal like 1Y signal. Then we try to find a binary that best match the value of that signal. That means our binary output is actually a reference to the analog signal. For example, if our reference signal is like 5, our binary is 8-bit, that means the highest value for our binary number is 255, right? So if we have 5 poles, we would observe 255 in our digital converter. And if it is somewhere in the middle, like if you observe 2.5, we would see 128 from our binary output, right? If we keep on sampling the data, we can also reconstruct signal in a digital term, like in this one. We have an input signal. We keep on sampling with our analog to digital converter, then we can create a square wave that looks similar to the original signal. Actually, we use the analog to digital converter every day, like when you do sound recording or the way that I do video recording right now. Now, our Arduino already have A to D equipped inside the processor, the microcontroller. So you can just use the analog read function to read from the analog pin. In this example, I read an input from analog pin A0. Since the analog read will return a value, so I just declare a variable value to hold the data reading from the analog pin. Now let's see the demonstration. Maybe you understand what is the point of today's lab. In today's lab, you have to connect this potentiometer to the analog input pin of your Arduino board. You might want to consult this document, page 118, to see the layout of the analog pin. Okay, so basically you have to connect the red wire to the VCC, the black wire on the other end to the ground, and the input to the A0 pin like this. Then for exercise number 2, connect this one to your digital 0 to digital 7 port, right? And later for the last one, you have to connect this 7 segment to the output port like this. Here is the first lab. You can just copy the code from the lab sheet. Basically, I read the analog input, put it in a variable value, and I calculate the voltage by using this equation. Alright, now let's see how it works. Well, in this exercise, I just want you to see what happens when you turn the potentiometers. Here, I try to turn the potentiometer. This is what happens. The value would get higher and higher until it reaches the maximum value, 1023, like this. And I can also turn it down. Well, in reality, the potentiometer may be replaced with your thermometers to measure temperatures, or pressure meters, humidity meters, or even accelerometers to measure the speed in your car. Okay, this is exercise number 2. Well, I didn't do anything much. I just leave the analog value and use that value as a delay between the blink. See the result from exercise number 2. Well, you would see the blink like this, and when I turn the potentiometer like this, you would see that it blinks faster. If I turn it another way, it's gonna be slower. Like this. This is exercise number 3. Well, basically, I just modify the first program and import the external port extension from the previous lab to use it, like this. Okay, now I calculate the volt and then display that value to the 7 segment, just like that. Alright, this is what you will get from the last exercise. When you turn the volume, basically you adjust the voltage to the analog pin. So I just want you to calculate and display the voltage to the 7 segment. If I keep on turning, I got more volt, and then the highest volt that I will get is 5. If I turning it down, it goes down like this. Alright, that's it for today. Hopefully you enjoy the show. Have fun, stay cool, and see you next week.